Hi, Polydoorway here. Today we're gonna finalize our wood barrel modeling. So let's see what we're gonna learn today. First, we are going to create the bolts of the barrel. Then we're gonna create the top and the bottom covers of the barrel. Then we're gonna finalize by creating some colors. So let's start. In the last video, we left off with the shape of the barrel and the rings modeled. Now, let's start by creating the bolt. So we're gonna grab our ring curve null that has the curves for the rings. And we're gonna start the bolt by these curves. So let's grab a frame, polyframe. Let's connect it. Here we are going to use point, tile to add, and we're gonna set up the normal vector by using the tangent name. So we turn off normal name, and here in the tangent name, we're gonna set it to n. We need to invert these normals. So let's grab a wrangle node. Let's name it. Normals and offset. We're gonna create a little offset too. So here, at n equals minus at n. So with this little expression, we inverted the normals. Now let's give a little offset by pushing the points along these normals. So at p plus equals the channel offset times at n. Let's make this expression at parentheses, semicolon, and let's create this channel. Now we can offset these rings a little bit. To make it procedural, we're gonna grab the length that we give to our rings. So this value, let's copy this parameter, and here right click, paste relative values, and we only need the half of it, so times 0.5. Okay, now we are going to create some styles for the placement of the bolt. Let's grab a wrangle node. First, let's create a little expression to remove some points along a step number. So let's name it. Step it removal. Let's color it head. Now let's create the expression. Each step equals the channel. Let's call it step. Let's create this channel right away. If at pit none, we are going to get the remainder of the pitch none along this step. If the remainder is different from 0, we are going to remove this point. 0, PT now. So here we change the step. We are removing some points. Nice. So this will be the first option to create our bolt. Let's create a second option. We are going to grab a rainbow node again. Connected. Let's name it random removal PTs. Let's color it red 2. Now let's create some properties. Float seed equals channel feed, and we are going to create a threshold property too. Threshold equals channel threshold. Let's create these properties. Nice. Now let's create a random number. Float rand num equals rand of fit num plus feed if threshold is less than rand num. We are going to remove the point. Now, if we change the number of the threshold, if it's 1, we are not deleting any point. And if the threshold is less than 1, we are going to delete some random points. And if we change the seed, we change the points that are removing. Nice. Let's grab a switch node to change the style of the removal. Let's name it toggle bolts insertion. Nice. Now we are going to create the bolt geometry. Let's grab a tube. Let's change the orientation to the axis. The radius will be 1, but we are going to change the radius scale. Let's grab a small value. And the height of the tube will be a small value too. Nice. We only need 8 columns of resolution because it's a small geometry. Let's create a polyfill to close this hole. We are going to create the group for this hole, and we only need single polygon in the fill mode. Nice. Let's call this group caps GRP or group. Then I'm going to create an edge group to initialize our UVs. So I'm gonna create a group node. Let's call scene GRP. Here in the group name, we're going to use an expression $OS. This expression will grab the name of the node. So our group will be called scene GRP. We are going to change the group type to edges. And we are going to turn off the base group. And we are going to use keeping bounding regions. We are going to use a bounding box. So here, in the X size, we need a really small value. In the Y size 2. And here in the Z size, we are going to use the bbox expression. 0, Z size. Oops, bbox, yes. And the center, we are going to use the position of the first point. So here, we are going to use point, the first input. We are going to grab the first point. We are going to see the position of this point. And we are going to grab the X value of this position. So it's here in the right side of the tube. To ensure that we will always get this side, let's create some expressions here in the Y and Z. So here in the Z, let's use the synthroid function, 0, Z, Z. In the Z side, we can give a little offset. So after the bbox expression, let's add a really small value. And here in the Y size, let's grab the centroids too. Nice. So this group will be the theme of our UV. Now we are going to create the scene using the UV auto scene node. We need to exclude the group of the caps. So let's go back to polyfill, copy this cap group, paste it here with exclamation point. Now we are excluding this group, and here we are going to include the scene that we created before. So scenes GRP. Let's see with the UV flatten and create some UVs. Let's change to preserve scene and use this name here in the flattening constraint. Nice. I think we only need to change the value here in the auto theme. So let's go back. Let's raise a little bit the mesh threshold. Nice. And now we have proper UVs for this tube. Now let's use the copy to point node. Oops. Now we have proper bolts for our barrel. Let's see the barrel and the bolts together. Let's create a null and name this null geo bolt. Let's color this null blue. And we have finished the bolt. Now, to create the top and the bottom covers, we need to find the ring that touches the inside of the barrel. So we are going to use the same logic that we have here to create the external rings. So let's copy this, Ctrl C, Ctrl V. And we need to change this logic a little bit, because here we are creating the distance between the external side of the wood barrel, and now we need to find the distance between the inside of the wood barrel. So here, let's see what is going on. We have our line. Let's turn off the bolt visualization. We carve a little bit on both sides. I think we only need to carve in the bottom. So the second U will be 1. We don't need to create additional rings. So let's delete the number of rings. And we don't need this transform node too, because this transform node will offset the line to touch the outside of the barrel. So let's delete this one too. Let's see how the ray manages this. Yes. Now our points are touching the inside of the barrel. This will be the basis of our cover geometry. So our ring geometry is inverted right now. So I think we need to delete this transform. No, maybe we need to rotate it. Yes. But we have a little problem here, because the top geometry needs to look outside of the barrel, but the bottom geometry needs to look outside too. So here, before the copy to point node, we need to set proper normals. So let's create a random node. Let's name it set normals. And here we are going to grab the position of the neighbor point. So vector pos is equal to the point of the first input 0. We are going to grab position, and the point number will be pitch num plus 1, and we are going to get the remainder along the total points. So n points, the first input. Now our normal will be at n equals normalized cos minus at p. Let's delete this transform, and I think we need to change the direction here of the circle. Now this face is pointing up and this face is pointing down, because our normal now has this direction. The top point is pointing down and the bottom point is pointing up. Nice. Let's move on. Now we need an attribute to mark this top geometry and this bottom geometry. So let's create another angle node. Let's grab the center of our geometry. So vector bbox is equal get bbox center of the first input. If at p dot y is greater than bbox dot y, then we are going to create an attribute, an integer attribute. So I at index is equal to 0, else I at index is equal to 1. And this wrangle needs to run over primitives. So let's change here to primitives. Now we have the index attribute. Let's name it here, index attribute. Let's color it yellow. Now we need to find a way to cut our geometry so we can give some planks. So here we are going to use the divide node. We are going to turn off convex polygons, and we are going to turn on breaker polygons. Here we only need divisions in the z direction. So here in the x size we are going to set a big number, in the y 2, and here we are going to find the size of this geometry in the z direction, this direction here, but we need to divide by a value that will determine how many planks these covers will have. So we are going to create a parameter. So here in the gear, edit parameter interface, we are going to create an integer. Let's call it number of planks. Let's give it a name too. Cover number division. Apply, accept. Let's give some default values. And here in the z size, we are going to set an expression. Bbox of the first input, the z size divided by this attribute. So copy parameter, let's go back to our z size and paste relative reference. Now we have cutted our covers, and this attribute determines how many cuts we have. Nice. Now to create the proper depth, we are going to loop it. So we are going to grab for each primitive. Let's connect it. Let's give some space for our for each loop. Now here we are going to poly extrude it. Just by a tiny bit. We are going to turn on output back to have polygons here too. Now, let's grab the borders of our geometry. So let's create a group. Let's call it border edges, GRP. Here in the group name, let's use the expression $OS. Let's change the group type to edges. And here we are going to turn off basic group and turn on include by edges. Let's turn on mean edge angle. Nice. Let's change this value. So we only grab the borders. Let's grab a poly bevel. And we are going to use this group. Let's give a tiny value to. Oops. Nice. Now we have some planks on the cover. We can divide it to get rid of any endgones. Okay. Let's see with our barrel. Nice. But I think that the top one is a little bit small. So let's use our index attribute. We are going to use the split. Here we are going to use at index equals 1. Group type primitives, invert selection. Now this first input represents our top cover and the second one represents the bottom one. Let's create a transform node. Let's call it offset. And here in the uniform scale, we are going to give a little bit of scale. But the pivot transform needs to be in the center of the geometry. So here we are going to type $CEX. In the Y value, we are going to use $CEY. And in the Z value, we are going to use $CEV. Nice. Now let's create a switch node to give the option to have this top cover or not. Let's create a null. connected to the switch and our top cover too. Nice. Let's name it toggle top cover. Now let's merge it together. Our top cover and our bottom cover. Nice. Now let's finish by creating a null. Let's name it geo covers and color it blue. This node will be important, so let's color it orange. This divide node is important too. Let's also rename it number of blanks. And this poly extrude is important too, and the poly bevel too. Now we have our covers. So let's create another merge. And merge our geometry. So to be an easier task, let's create an object merge. Let's grab this null. We don't need any transform, so let's change it to none. Let's name it to get geo covers. Now this node represents what we have in this null. Let's color it blue too. Let's copy it and change the object. Let's change the name to get geo bold. And here, let's delete this merge node. Let's create a null to indicate the rings. So geo rings. Let's color it blue. And this node represents our geometry. I think we already have it. Yes, it's this base null shape. Okay, let's delete it. Let's grab this to get objects nodes. Let's copy it again and change to get the rings geometry. Rings. To finish, let's grab this base barrel shape. Let's copy the object merge again, change the object, and change the name. Get geo barrel. Now let's grab all these object merge nodes. Let's put here and use the merge. Let's organize a little bit. Let's connect all these nodes to the merge. Nice, now we have our model completed. To finish this off, let's create some colors. It will be pretty easy. We are going to create a color node. Let's copy this color node and connect the other object merges. Nice. Now for the barrel, let's give it a brown color. Okay. For the rings, let's give it a bluish color, very desaturated one. For the bolt, let's give it a gray color. And for the covers, let's give it a brownish color too. Let's see all together. Nice. Let's create a new. Let's name it Alt Geo Wood Barrel. Let's color it blue too. And we can give some normals too. Let's grab the normal node. Connected between the merge and the null. Let's change our visualization. And changing the wedging method to biface area. Nice. And now we have finished our wood barrel. In the next video, we are going to set up the properties for the HJ and test it inside Unity. So we can create some materials and link some textures. If you like this kind of content, leave a comment and let me know what you think. Thank you so much and have a nice day.